Welcome to the deep dive. Today, you've given us some really fascinating source material. It presents this incredibly unifying view of reality, almost radical, you could say.
It really is. The core idea sounds almost too simple at first glance.
Exactly. That everything we wrap up in complex jargon,
hmm
physics, chemistry, biology, even society, it's all fundamentally just motion.
hmm
The sources argue we've basically spent centuries just renaming doing and flow. We give them fancy labels like mass or consciousness.
Right.
So our mission today is to unpack that, to give you the translation key offered in these sources. We're translating the big abstract concepts back into the language of dynamics, of flow.
Think of it as a shortcut.
Yeah.
A way to see the common ground, the kinetic reality beneath all these different fields.
So where do we start with this translation?
Well, the key is to look past the labels, like you said.
Yeah.
Focus on the dynamics, the verbs, not the static nouns.
Right.
We need to start with the absolute basics, the grammar of this motion-centric view, the foundations.
Okay, the grammar. Lay it out for us.
All right. So even concepts we think are totally static, they're actually dynamic here.
Yeah.
Take space. It's not emptiness. It's defined as background motion.
Background motion, like a field.
Exactly. It's the unresolved ambient field patterns that everything else, all the defined patterns, ride on. It's the medium itself.
Okay, so space is the carrier wave. Then what about time? We usually picture it as this river flowing in one direction.
It's much simpler in this framework. Time is just the rate of change.
Rate of change.
Yeah, how quickly a pattern updates its configuration. If nothing changes, there's effectively no time passing for that pattern.
So clocks.
Clocks are just really stable, repeating motion loops. Pendulums, quartz vibrations, atomic transitions. They're just sync devices. They let different patterns agree on their relative rates of change.
Right, okay. That's a different way to think about it. Let's get into the core physical concepts then. This is where the translation key feels like it could really click. If we talk about stuff, we usually start with mass. Here, mass is redefined. It's resistance to retuning.
Exactly. Resistance to retuning. So when you push something, try to change its velocity, what you feel is its resistance to changing its internal rhythm, its pattern of, let's say, circulation or oscillation.
So it's like stubbornness, how committed a motion pattern is to its current state.
That's a great way to put it. It's the pattern's inertia.
Wait, so mass isn't a measure of stuff at all. It's a property of the motion itself.
Precisely. You don't need some static entity possessing mass.
Yeah.
You just need a stable, self-maintaining motion pattern that resists having its frequency, its rhythm, or its trajectory altered.
Okay, mine's slightly blown already. So if mass is resistance, then energy logically follows as the capacity to overcome that resistance.
You got it. Energy is framed as tension and motion, its capacity stored purely in the configuration, in the setup of the motion.
Like a coiled spring.
Exactly like a coiled spring, or highly structured flow that's currently constrained. It's not a thing you have, it's a state, a setup that promises action, promises change, when those constraints loosen.
So resistance, mass, and capacity energy are about pattern and constraint. This leads us straight to the quantum world, doesn't it? To particles. If they aren't tiny balls, what are they in this motion framework?
This is where the source offers elegant simplicity, I think.
Sure.
Elementary particles are structured motion. They're not things moving, they are the motion.
Okay, so what's light? Photons.
Photons are described as oscillatory structured motion, traveling loops in the electromagnetic field, basically. They carry phase information that's what we perceive as frequency or color.
And electrons. They always seem so point-like, but also wave-like. How does motion explain that?
They're seen as stable standing wave patterns, or sometimes the term solitonic is used.
Solitonic. What's that?
It sounds complex, but it just means the wave pattern is self-reinforcing. It holds its shape and identity perfectly as it moves. It appears point-like in experiments, not because it's infinitely small, but because its structure is so stable and localized. Its identity comes from its persistent internal circulation, which we call spin.
Ah, okay. That clicks. And the Higgs field. The thing that supposedly gives particles mass.
If mass is resistance to retuning, then the Higgs field becomes, well, the sync background. It's the field that affects how much resistance other motion patterns feel when they try to propagate or change.
Like wading through treacle. It makes it harder for patterns to move or change speed.
Kind of, yeah.
Yeah.
Or like trying to move through a dense synchronized crowd. It changes the inertia, the resistance, the mass of the patterns moving through it.
Okay, let's zoom out. From particles to everyday matter, how does this explain atoms?
Atoms are seen as standing wave nests. You have the nucleus, which is a very dense, stable core pattern, and then the electrons exist as specific allowed modes, specific standing waves, defined by the boundaries set by that nucleus.
And the properties we see in materials, hardness, conductivity, these emerge from how those patterns interact. Like, why is a diamond so incredibly hard?
It's a perfect example of coherence in this view. The source calls it tightly phase-locked carbon modes,
Jeez.
meaning the motion patterns of the carbon atoms in the lattice are perfectly synchronized, perfectly aligned, and rigidly connected. To scratch a diamond, you have to input a huge amount of energy to break that synchronized lock between the patterns.
Okay, so extreme rigidity is extreme sync. What about the opposite? Ultimate free flow superconductors.
They become this pure example of frictionless phase lock.
Hmm.
Below a critical temperature, all the electron motions align perfectly. Coherence totally wins out. The current, which is just organized electron motion, flows with zero resistance, zero leak.
Amazing. And at the messy end of the spectrum, glasses.
Glasses are described as arrested motion. Imagine freezing a liquid very suddenly. The structural modes, the patterns, get stuck out of equilibrium. They're frozen in disorganized, frustrated flow patterns.
Right, so micro world, stable patterns, phase locks. Now let's scale up. The big world, geology, weather, fluids. You said it's about gradients driving flow.
Exactly. Gradients define the direction. We already touched on energy as potential.
Yeah.
Well, force in this view is simply a motion gradient.
A slope.
Yeah, a slope in the motion field. If you feel acceleration, you're basically sliding down a gradient in some underlying motion field, like gravity.
And resistance to flow, like in honey, viscosity.
That's simply shear leak. How much of the organized motion energy gets lost to internal friction when different layers of the fluid try to slide past each other? More leak, more viscosity.
Makes sense. And larger systems, like convection, when hot air rises.
That's translated as a buoyant loop. Hot fluid means faster internal motion, faster updates, lower effective density, so it rises. Cool fluid is slower, denser, so it falls. It's a closed loop driven purely by these differences in motion intensity, which we measure as temperature.
Okay, now for the really complex flows, turbulence. It looks like pure chaos.
But according to this perspective, it's actually a cascade of motion. Big organized swirls eddies break down, feeding their motion energy into smaller and smaller eddies. The energy flows down the scales, but the total motion is sort of conserved in that cascade.
Huh, organized chaos. What about huge weather systems, tornadoes, hurricanes?
These are seen as highly organized vortex loops. They're self-sustaining motion patterns fed continuously by massive thermal gradients, differences in heat energy between, say, the ocean and the upper atmosphere.
And something sudden like lightning?
That's runaway charge motion. The electric field builds up such a steep gradient that it forces a breakdown channel. The charge motion finds the path of least resistance and rushes through it incredibly quickly.
Okay, let's go even bigger. Planetary scale. You're saying even continents moving follows these rules. Plate tectonics.
Defined here as mantle convection loops. It's incredibly slow, solid-state creep, but it's still motion. Viscous rock flowing in huge loops carries the continental plates across the surface like rafts on a very, very slow river.
Wow. Okay, cosmic scale. Black holes. We usually think of them as these static sinkholes.
But here, they're extreme convergence kernels, ultimate whirlpools where space-time motion itself is converging intensely.
In the event horizon.
That acts as a sync boundary. It's the point of no return, because beyond it, any incoming motion pattern can no longer synchronize or coordinate its rate of change with the outside universe. It's causally disconnected. When they merge, the gravitational waves we detect are the final ring down, the motion pattern settling.
This motion framework makes some of the biggest cosmic mysteries sound almost mundane, like bookkeeping. Dark matter is called unseen motion bookkeeping.
Yeah, it sounds a bit like that, doesn't it?
It does sound a little like a clever fudge factor, though. If dark matter is just bookkeeping, how does this perspective help us actually find it? Or prove its real motion?
Well, it shifts the focus, you see. The observations tell us there's extra gravity, extra convergence, holding galaxies together. So this framework says that must be caused by some form of coherent motion, just motion modes that don't interact with light.
So not necessarily particles.
Not necessarily particles in the traditional sense. We should be looking for evidence of large-scale, invisible flows or patterns that only interact gravitationally. It changes the search strategy from find the particle to map the unseen gravitational motion.
Interesting. And dark energy, the accelerating expansion.
That's interpreted as a large-scale drift pressure, a very gentle, persistent outward push inherent in the background motion of space-time itself.
And the oldest light we see, the CMB, the cosmic microwave background.
That's the ancient motion fossil. It's literally the imprint of sound waves, pressure waves, density fluctuations, waves of motion that were traveling through the early universe. When the universe cooled enough for light to travel freely, those patterns were frozen into the light we now see as microwaves.
Okay, this is where it gets really mind-bending for me. Applying this motion key to life, to mind, to us, biology suddenly becomes just incredibly complex, controlled motion.
It's perhaps the ultimate expression of structure regulating flow, yes. Take DNA. It's described as a programmable motion template. Its sequence isn't just static information. It directly tunes the machinery that builds proteins. It sets the rules for the specific chemical motion loops that can happen in a cell, dictating what structures get built and maintained.
And enzymes, the catalysts.
They were reaction mode matchers. They physically grab the reactant molecules, orient them, perfectly align their motion patterns, you could say, to dramatically lower the energy needed for a chemical change. They make the required motion happen efficiently. They choreograph the chemical dance.
And the cell's power generator, ATP synthase. It's often called a motor.
Here, it's explicitly defined as a rotary motor. It's driven by the flow of protons across a membrane. Pure mechanical motion protons flowing down a gradient turns this tiny protein machine, which then generates ATP, the cell's energy currency.
Yeah.
It's direct conversion of flow into stored chemical potential. Nanoscale engineering based on motion.
Amazing. So our own internal world, our brains, our thoughts, they follow these rules too. Neurons.
Described as generating spike trains. These are propagating motion pulses, electrical signals traveling very efficiently along the nerve fibers. Highly structured, low-loss motion carrying information.
And memory. How can something as ephemeral as memory be motion?
It's defined as present tuning. Memories aren't stored like files in a computer. They are motion patterns engraved into the physical structure of the brain in the connections between neurons. Recalling a memory means rerunning that specific pattern of neural motion, reinstantiating it in the present.
Which brings us to the big one. Consciousness. Free will. If we're just complex motion patterns, where's the choice?
This is maybe the most speculative but fascinating part. The source interprets free will as resync bandwidth.
Resync bandwidth.
Yeah. Imagine your brain is constantly exploring multiple possible motion patterns, potential thoughts, potential actions. Free will, in this view, is the capacity your system has to select one of those potential patterns and stabilize it. To impose a coherent lock on that chosen pattern, overriding the inertia of the others, it's about your available bandwidth to select and maintain a specific synchronized state amidst competing possibilities.
So decision-making is like tuning a radio, finding and locking onto a specific frequency among the noise.
That's a decent analogy. It's pattern management under constraint.
Okay, moving outwards again. Human system society, these are also just loops and flows.
They are. When viewed through this lens, language itself becomes shared compression of motion.
Yeah.
We take complex, messy individual thoughts or perceptions, internal motions, and compress them into stable, agreed-upon codes, sounds, symbols. This allows efficient, low-loss transmission of these patterns between minds. Even something like markets, which we think of as driven by calculation and rational choice.
Are flows with feedback, exactly. Money flows, goods flow, information flows. Price signals act as feedback mechanisms that couple the motions of millions of individual agents, constantly trying to find balance, but always dynamic, always shifting.
In culture, traditions, norms.
Those are framed as slow oscillations. Very large-scale motion patterns, styles, beliefs, social structures that cycle and evolve over generations. They have immense inertia, but they do change, just very slowly.
Right. We've got the translation key now. Let's do a quick tour of technology and some everyday things, seeing the motion behind the mask.
Good idea.
Transistors, the heart of all our electronics.
Simple. Gatekeepers of electron motion. A tiny signal controls a valve, shaping a much larger flow of electrons. Pure motion control.
Lasers.
Lasers are about gain-beating leak in a single mode. You amplify one specific pattern of light motion so intensely that it completely dominates, forcing all the photons into perfect sync, perfect coherence.
And a basic clock. We touched on this. Just a stable loop. A physical system, pendulum, crystal, atom, designed to oscillate at a very precise frequency to maintain its motion pattern incredibly consistently, resisting disturbances.
It's also cool how this explains little everyday puzzles, things we see but don't really think about. Things that seem like weird effects but are just flow.
Absolutely, like the coffee ring effect, why the grounds end up at the edge of the spill.
Yeah, why is that?
It's an edge-driven conveyor. The edge of the drop evaporates fastest, pulling fluid outwards to replace it. This flow carries the particles to the edge and pins them there. Simple fluid motion gradient.
Huh. Okay, and why do Cheerios clump together in the milk bowl? The Cheerio effect.
That's meniscus coupling. Each Cheerio creates a little dip in the milk surface. These dips are like tiny gravitational wells. The surface tension pulls them together to minimize the overall surface curvature. They're writing motion gradients on the liquid surface.
And the classic shower mystery. Why does the shower curtain billow inwards?
That's a pressure mode caused by the water jet. The fast-moving water drags air along with it. It's called entrainment. This creates a lower pressure zone inside the shower compared to the bathroom outside.
So the higher pressure outside just pushes the curtain in?
Exactly. It's flowing down the pressure gradient, all just motion dynamics.
This has been, well, a complete perspective shift, translating pretty much everything back into the language of verbs of dynamics. So what's the grand synthesis here, the big takeaway?
The sources really conclude that if something, anything, rings at a note like an atom, flows down a gradient like a river or heat, or stabilizes under feedback like a thermostat or an ecosystem, it's just motion wearing a different hat.
Different labels for the same fundamental process.
Right. The core process, whether it's physics, life, or society, it always seems to boil down to structured motion, raising sink, cutting leak, and shaping couplings between patterns.
So for you listening, the real action item is to try and internalize this framework. We have the equations, the theories, it's like the sheet music. But the sources argue the real insight, the deeper understanding, comes from remembering the performance. Remembering that the sheet music describes dynamic action, describes motion.
So here's the final thought, the provocation. The next time you encounter something complex, a scientific puzzle, a market trend, a biological process, even a social dynamic, resist the urge to just find a static definition, a noun. Instead, ask yourself, what is the motion attempting to stabilize here? What patterns are forming, competing, or locking together? And what's its sync bandwidth? How well can it coordinate and maintain its structure against disturbances? Focus on the flow, the dynamics, the quality of the motion, and you might find that the biggest mysteries start to look like manageable patterns after all.